In this section, we're going to discuss the atomic theory, which I've alluded to some as we've gone through the last chapter and this chapter. But here we can talk about what a molecule actually is. And we define a molecule to imply a single element or compound that represents a particular substance. So when we talk about oxygen floating around in the air, oxygen occurs naturally in the air as O2. It's two oxygen molecules stuck together. And so when we talk about oxygen, a molecule of oxygen, we're not just talking about a single oxygen atom. We're talking about this combination of the two, this molecule as it occurs. Ammonia is similar. When we talk about a molecule of ammonia, we're talking about a single molecule of one nitrogen and three hydrogens combined together in this way. Gases like helium and neon exist as single atoms. And so when we refer to those, a molecule of helium is just one atom of helium. But a molecule of oxygen is O2. A molecule of hydrogen is H2. A molecule of water is H2O. Here's a molecule of ethyl alcohol. We represent molecules by their chemical formulas. It's the combination of the symbols that we use to represent each of the elements. And then we use a subscript to tell you how many of those atoms are in that molecule. So for example, H2O, which is water, will tell you there are two hydrogen atoms and one oxygen atom in a single molecule of water. And we give this one a common name, and we'll discuss naming them some later. But similarly, here methane has one carbon and four hydrogen atoms. But it's one molecule of methane. And so we represent these different substances using their chemical formulas, using the atoms that they're made out of. Now, not every substance is going to contain a molecule. Okay, sodium chloride is formed from sodium ions, which are positive because they can easily lose an electron, and chloride ions, which are negative because they can easily gain an electron. More on that in a few sections. But then what happens is the two are immediately attracted to one another, and they form this type of lattice structure that you see here. So there's no way to have an individual atom of sodium chloride. They're all going to be stuck together, all side by side, right, in this lattice structure. This is what gives table salt its look. That's why it looks like little rocks, because you can't break it up into individual pieces. Here, because they're held together by the electric force, you're always going to have the same number of atoms. If you break a chunk off of it, you can't break it down into one sodium chloride atom. Now, anytime that an atom is formed or a compound is formed, energy is given off, much like energy is given off from the nucleus as you add nucleons. This makes those atoms more stable, which means you have to do something to break them back apart. You have to put energy back into it to separate the molecules back into their constituent atoms.